Next, we'll talk about the purpose of cooling load calculation. Okay, the primary objective of the cooling load calculation is to provide data required to design a HVAC system and to select a HVAC equipment. So, why we are doing the heat load calculation? For the selection of HVAC equipment, basically. Okay, and to understand what is the heat inside the space. Okay, so this is one of the method. Uh, if you go to the space, right? This is a space. You can able to see the different type of heats. Okay, the external, you can say, you can talk about ceiling and roof, solar heat, windows, walls, floor. Then you can say that any outside temperature, whatever through the outside temperature to the inside, which is affecting, that is called external load. Okay, and when you talk about internal, you can say lighting, you can talk about any appliances, then you can talk about people inside the space. Okay, so that will have, that is the internal load. So you have a, yeah, yes.
And how this ventilation is considered as internal, because the ventilation is open to external part, like
No, ventilation is external only. This is external. This is coming from outside to inside. Okay.
Okay.
When it comes from outside to inside, you have a sensible load and also you have a latent load, because there is a moisture in the air.
Yes.
So ventilation also external.
External. Okay.
Yeah, basically ventilation also external. Okay.
Fine.
Okay. You can see that moisture removal and the latent load. Okay. So when you talk about external, okay, you can see that this is all external. I don't know why they have considered ventilation as an internal. Okay, because it is ventilation is coming from external to internal, right? Because it is an infiltration.
Yes. Correct.
Yeah, I don't know the reason. Yeah, but basically ventilation is the external load only, because say for example, you have a cracks, okay, through the wall cracks or through the door cracks. Okay, your that is called infiltration basically. Okay, this is infiltration. Correct. Okay, so this ventilation, they are considering it as what? It is from external to internal only, right? Yes. Okay, so maybe it is from external to internal, and internal it is affecting the load. Okay, see, you are bringing ventilation air from outside to inside. Okay, so the inside it is affecting, so that space. So that is that is the way they may consider as an internal.
Okay.
Just one doubt.
Yeah.
So just wonder when it says ventilation, let's say just considering a simple FAHU, it will take out the air from the cool space. It takes the extract air back. Yes.
Okay.
So could this be the reason it's considered in the internal part?
Yeah, that is what it is affecting the internal space. Okay. So that is the reason they have considered as an internal portion, right?
Okay.
So that is, so whatever the external load is a part of roof, walls, window, solar. So this is all you can talk about purely sensible, right? Or you can say that the shaded portion is the latent. Okay, so this shaded portion is the latent, and the unshaded portion is sensible load. Okay, so when you talk about people having a both latent and sensible. Okay, and when you talk about appliances, you have a both latent and sensible. Ventilation loads, you have both latent and sensible. Infiltration, yes, latent and sensible. Then if you have any other miscellaneous load. So this is the basic to understanding of what is external and what is internal. Okay, this is a simple air conditioning. Okay, you can talk about, there is a one of the air conditioning machine which you are going to supply the air by means of ducting, and you are going to take the return air. Okay, and you are going to recycle, and also you will provide some of the air outside, and you will take some of the air from outside. So this is just a small picture to understand sensible heat, relative sensible heat, relative latent heat. Okay, then not efficient, effective, or effective, relative sensible heat. Okay, so this is the whatever you have a different condition, they have just give the details. Okay, clear, right? And we will see in more detail. Okay, and this is a sensible cooling load and latent cooling load. So we are going to calculate the sensible cooling load and latent cooling load. When you go to the psychometric, when you go to the HAP calculation report, okay, you can able to calculate the total. There is a table. Okay, it will estimate what is the total sensible load in that particular space, and also what is the latent cooling load in that particular space. We can see when we complete the HAP calculations, right? Okay, so you can able to understand cooling load comprises of both sensible and latent loads. Actually, one sensible heat or the sensible load occurs in the room, and latent load is not part of the room. Okay, so latent heat is a part of change of state. So inside the room it appears only as moisture, but no latent heat exists or transfer. When moisture from the return air is condensed back to the water on the cooling coil, latent heat of condensation is absorbed and it is called the latent heat is load. Okay, so you can see that sensible load in the room, right? You have electric lighting is a sensible load. Then you can talk about computer room is a sensible load. Okay, and infiltration, when it comes, you have a both latent and sensible. Okay, occupant, you have a both latent and sensible. Okay, then you have a solar radiation is purely sensible load. Okay, then the through the wall, through the roof, through the ceiling, everything is a sensible load. Okay, clear, right? So when you design the air conditioning, you have to design the air conditioning for both for sensible and for the latent. Okay. Okay, then you can talk about heat from where. Okay, so this from the sun, right? Solar. The heat coming from the solar. Let me accept. Okay, you can see that depends upon the solar location. Okay, or the earth location. You will feel the different temperature in different part of the world. Okay, if you go to India, you have a different temperature. If you go to UAE, you have a different temperature. If you go to Europe, you have a different temperature. Okay, so that is the you can able to identify temperature and relative humidity in different part of the world. Okay, you have a different conditions, right? Different dry bulb, different wet bulb, different RH in different part of the world. Okay, and from there we are going to treat the air to the human comfort requirement. The human comfort requirement is applicable for everywhere. Okay, if you are in London, you are going to bring it down to 28.3 to 24 degrees Celsius. If you are in Delhi, you are going to bring down from 43.8 to 24 degrees Celsius. Okay, so the human comfort requirement is uniform everywhere. Okay, but depends upon outdoor air you are going to treat the air. Okay, so this is the sun path basically. Okay, so you have a direction from uh, one direction to other direction, right? Okay, so this direction, say for example, when you talk about one of the building, okay, and you have a sun will be transferring from one side to another side. Okay, this particular side, okay, you have a different load, and this particular side you have a different load. This particular side you have a different load, depends upon the sun intensity, solar intensity. Okay, when you talk about the morning, you have a less intensity. In the afternoon, you have a high intensity. Maybe in the 3 o'clock, you have a much more intensity. Okay, so that depends upon that. Your heat load will vary. Your heat space will vary.
But
Yeah.
but again, this will be considered during the design, because design we would consider the maximum load. No?
Yeah, maximum load. Yeah, that is why that depends upon the
Uh,
direction. See, for example, okay, if you talk about any of the high risk apartment, okay, say for example, I have a one room here, the same volume, everything, same design factor, and you have a room, the same design factor, right? Okay, say for example, I have a solar transfer travel from one location to another location. Okay, so this value will vary depends upon the intensity, right? The heat intensity from the sun. Okay, I will also show you that heat intensity. Okay, in
I
the coming
think,
slide.
Bharani,
Yeah.
maybe we can say that when we are doing the heat load calculation for any particular space,
Yeah.
we will be saying what is the north side materials like a wall or glazing mirror, what will be on the south side, what will be on the west side. Maybe
Yeah.
am I correct? We'll be
Yeah.
entering this
Yeah.
information, right?
Yeah, you're correct actually, basically. But what is
Yeah,
happening when you have a residential building? Okay, you will
yeah,
use the same type of wall here, and you will use the same type of wall here, right? So that
correct.
doesn't that will be that is not applicable. Okay, basically
Mm.
when you talk about
The
SciComm, the ASHRAE design condition. Okay, maybe I can go to the ASHRAE design condition, right? This is the ASHRAE design condition, right?
mm,
When you remember last week we have seen. Okay, in that particular chart, maybe I can able to show you one of the value. Okay, one of the location I have just taken the value here. Can you see this value here? All sky solar radiation, right?
Yeah.
Okay, so you can see that different intensity. Okay, you can see that value in kilowatt hour per meter square. Daily solar sky solar radiation, right?
Mm-hmm.
So you can see that, say for example, during the month of June, you can see that very high intensity, right, from the solar.
Yeah. Solar, correct.
Yeah. So this will vary depends upon the month, and also it will vary depends upon the direction, and this
Mhm.
also will vary depends upon the timing in the same particular day. Say for example, morning you can able to go outside, okay, but afternoon you cannot go
Mhm.
outside because it is having high intensity, right? So this heat,
Correct.
the same heat intensity will affect your heat load as well.
Okay, Palni, I have one more question.
Yeah.
Now we are focusing more on the cooling part. How about the
Yes.
heating part?
No, heating
Like, for
part.
example, in London, so in the winter we have to do heating, right? In
Yes.
Europe.
Yes.
So
Yes.
how are we going to speak about that in the coming days about the how the heating calculation is done?
Yeah, actually
Oh,
speaking, when you do the heat load calculation, okay, of any part of the world, you will consider both summer and winter temperature, right?
okay.
Okay,
Mm-hmm.
say for example, okay, if I go to again the same guideline, right? Okay, if you go here, you can able to see this value. Say for example, n equal 20 years. Okay, or you
Yes.
can talk about extreme annual design condition. Okay, so
Mm.
what is the temperature here? Maximum temperature is 42.3 and 31.3, right? And
Yes.
also you can see the minimum temperature during
In
winter.
the winter.
It will be
Yeah.
10.4 and 5.1. Okay.
Okay. Okay.
Okay, if you talk about any of the normal air conditioning, right? Normal air conditioning machine, okay,
Mm.
you are going to talk about, say, for example, LG, or you are talking about Daikin, okay, they have
Mm.
a both option, okay. So, say, for example, you have a heating and also you have a cooling option,
Okay.
okay. Now,
Mm.
basically, in UAE, we don't speak anything about
Heating.
winter heating, okay, because the heating is not applicable here because during winter you can able to live with a comfort of 10.4 degrees Celsius or 15 degrees Celsius, something like that. Okay. When you talk
Correct.
about winter outside, this is the outside temperature 10.4 degrees Celsius. Okay. Okay.
Yeah.
This is similarly the same case. Okay. Just now, whatever we have calculated, what is the heat inside? Okay. The heat coming from occupant will not change during winter and during summer, right? Whatever you have a heat
Yeah.
from your body, it will emit the same heat, right? Maybe
Yes.
it will vary depends upon the activity, but the heat the amount of heat will be much more less, much more equivalent. Okay, the light heat from the light. Okay, whether during winter or during summer, it will be the same amount of heat will dissipate. Okay, your
Mm.
computer will dissipate a same amount of heat. Only change is your external portion. Okay, so there is a
Mm.
heat available inside your space. Okay, correct, clear, right?
Correct. Yes.
So assume that I have a outside temperature is 10.4 degrees Celsius, but when you go to internal, you may feel like a 15 degree or 18 degrees Celsius. When you go to inside the space,
Yeah.
okay. So that 18.4 is much more sufficient for the human to come to human to live, right? Maybe he
Yes.
can wear jacket or something like that. Okay, there is a thermal comfort. There is a, if you go to ASHRAE, there is a thermal comfort section is there. Okay, maybe I can share that section. You can go through, but it's not necessary to read all the pages. Okay,
Mm.
just to understand. Okay, now if you go to Europe countries, okay, say for example, assume that you are in London or somewhere in European countries, your temperature is very cold, right? Sometimes it will
Yes.
be minus. Okay, so you are going to heat, you are going to use the heating application. Okay, and what
Correct.
temperature to what temperature you are going to heat it, right? So that is called
Mm.
sensible heat. Sensible heat. Okay, so there is a value how to calculate the duct heater capacity. I think that also I have covered in my section how to calculate duct heater capacity. So you
Mm.
are going to add the duct heater, and what is the capacity of the duct heater will be calculated accordingly. How you are going to calculate the cooling coil?
Mm.
Okay, so you are going to calculate the duct heater. So say for example, at what temperature to what temperature you are going to bring it.
Fine.
Okay, so that actually either you are heating or cooling, it will be the same equation, heat equation. Okay, but we
Yeah.
will cover it. We will talk about that.
Okay.
Okay, and when you go to, this is the solar direction. Okay, depends upon the solar direction, your internal heat will be affected, right? If you have a,
Yeah.
depends upon the intensity. So that is why your temperature is very important. Your solar
So
temperature is very important.
just
Yeah,
yeah,
Fakhar.
okay. Just one. Let's say in this particular example, what you've drawn on the chart, there's a room on the right and there's a room on the left. Then the
Yes,
sun in
yes.
this scenario is going from left to right.
Okay.
Okay. So basically, when we calculate the load, if these are both similar rooms, let's say these are meeting rooms with similar requirements,
Okay.
uh, should we consider the Sankhya or we will consider both as equal? I mean, because just because the sun is moving from one side to other direction, we will consider both as equal and take the maximum load. No?
No, why you want to take maximum load when there is no load here, right? So you can able to calculate heat load for this area, and you can able to calculate load for this area. Because
This
see,
area.
if you are talking about 1 kilowatt difference, okay, when you
Mm,
talk about total whole year,
mm,
8670 hours, okay, there is a
mm.
lot of energy you will be using, right? Unwanted energy.
Okay.
Okay,
Okay.
so that is why you do the heat load calculation for this particular space and heat load calculation for this particular space. Okay,
Okay.
you will understand this value when we go to the HAP software. Okay,
Calculation.
you
Okay.
can able to see the HAP software different direction. You have a different heat intensity. Okay, that is already calculated here. Clear, right? Okay, so this is about a solar. Okay, then understanding U factor and R value, right? See, we talk about there is one of the wall. This is a basically conductive, right? Okay, so you can able to see different type of materials. Okay, so you have to calculate each and every material what is the resistance. Okay, that is factor is very important. If you know the resistance, you can able to calculate by using 1 by R. Okay, so this unit is watts per meter square Kelvin. Clear, right? So if you
Yeah,
come
this is
here,
what we discussed in the last class.
yeah,
Watts per
last class
meter
as
per
well.
Kelvin.
Yeah. So if you talk about typical wall U factor calculation, right? So you are going to calculate R1, R2, R3, R4, R5. What is R1? There is a moving air, and R2 is a cement plaster, okay, and R3 is the hollow cement blocks. So each and every material having a resistance value, okay. So by using this resistance value, you can see meter square Kelvin divided per watts, okay. So you can able to calculate what is the resistance in that particular material. If you go to Dubai municipality, there is a schedule given for each and every material. Okay, that is also I have attached in my folder. Okay, so some of the material. This particular material, actually, this is not part of the mechanical engineering scope. This particular value calculation. Okay, if you go to my folder, I have attached
So these values would be given by the designer itself or from
this.
the
This value will be given by the civil engineers.
civil engineer designer,
Yeah,
and we
designer.
will consider these values in our calculations.
In our calculation, because it is affecting our internal load, right? If you have
Correct.
a poor, if you use poor material, we have to use our air conditioning will be poor.
Higher
Okay,
capacity.
yeah, high capacity. Okay, if you are using good material, then your resistance is high, then your air conditioning capacity will be lower. So that is why this one of the factor. This is one of the important factor for the air conditioning design. Okay, you can see one of the table from by one of the civil engineer. You can see the different exterior. You can see the different material like brick wall, air space, thermal insulation. Okay, then you have a stone marble cladding. So each and every material having a resistance. Okay, you can add the resistance. Then if you divide by 1, you will get the value of U value. So this U value should not go beyond your municipality requirement, which we have seen in SAFAT regulation last week.
You mean
Clear,
the
right?
sum of all these R values, yeah?
Yeah, some
I
of the
mean,
R
the
value
sum
will
of all
be
this, sum
1
of
by
the R
U,
value, 1 by R will get the U value,
U
and
value,
Conductivity.
the total U value should be as per the municipality regulation. Yes.
municipality regulation. Yes.
Okay.
So if
I mean, just we won't go for each of the material to be used. Yeah. We'll take the sum total and see if it's
sum
under the
total, yeah,
regulation.
yes,
Yeah.
yes.
Okay.
So if you go to Dubai building regulations, you can able to see they have given the guideline, right? What is the maximum value you can apply? Say for example, if it is a roof or external wall for the silver type of building, you know that LEED requirement, right? So if you have a LEED, you have a silver building, you have a golden building, platinum building, depends upon the points available from the LEED. Okay, so if you are a silver building category, then you can go up to 0.57 for the external wall. Okay, And if you go to as per calculation, okay, you're meeting only 0.205, which is very good, right? You can go up to 0.5007, but based on your good material, you can able to stop at 0.205, right? So this value you will be using it in the calculation. This is the actual U value. But if you don't have actual U value, you can consider the maximum U value here. Clear, right? Fahad?
Clear, clear.
Yeah. So this is the way they calculate the U value for all the material. Say for example, if it is the wall, okay, and also I can show you one. There is one more folder. See, this is from the Dubai municipality requirement, right? You can able to see that external wall. You can apply different materials. They have already given 0.57 watts per meter square Kelvin. So whenever the civil engineer they do the calculation, okay, when they submit for municipality approval, they should follow this guideline, right? If it is for silver Suffolk building, or you can able to select the different value for platinum, then this value will change automatically, right? So this is their guideline. Okay. So whenever you select the material, should not go beyond this value. You can see that U value, okay, should be 0.42. If it goes more than that, the municipality will reject. Okay. If you talk about external drop beam, should be 0.42, column 0.42, roof 0.3. So they have given the value here. Then if you go to material, right, different materials from different manufacturer, okay, they also provide what is the resistance value here, R value. Okay, I think this one doesn't have R value, but you can see the other values like K factor, density. Okay, this is directly from municipality, this particular schedule. Okay, similarly for the glazing. Similarly for the glazing also, they have selected the, depends upon the direction, okay, depends upon the number of glasses, U resistance value. This particular value also should not go. Yeah, they have given the table here, right? This particular table, same as per this table. This table. Okay, so based on that, you can able to calculate your value of the this also will be done by the civil engineer for the glasses, which type of glass they are selecting. Okay, in different what is the size of the glass, okay, and what is the area of the glass, which external wall, okay, if it is a roof area, what is the type of the glass they are selecting, but they should limit within this value. Okay, you have a glass, you have a 0 to 40 percentage of the area, or 40 to 60 percentage, or greater than 60 percentage. What is the value you have to consider here? Clear, right? Okay, so this is the typical U value. Okay, basically we are going to calculate each and every heat, right? If I open one of the equation, see, basically you can see that steps for cooling load calculation. Okay, you are going to calculate the heat for each and every space. Okay, like wall, roof, door, glass, solar glass, lighting, people, miscellaneous, electric equipment, partition, infiltration, ventilation. Okay, so this particular all the value having a both sensible and latent, that you know, right? Okay, so when you add total sensible and when you add total latent, so summation of sensible plus latent will be the total heat. Okay, so depends upon that heat you are going to select the machine. Okay, now we are going to see that we are going to understand. Okay, like we started with the solar, right? We have started with solar, outside sun, right? Then after that we started with the wall, roof, door, glass, everything. Okay, so if you go to the particular slide, okay, you can able to calculate the typical U value for the wall, right? And this is for the roof. Okay, depends upon the material. What is the material, you can able to calculate the U value for the roof. Okay, you can see the temperature outside and temperature internal will vary, depends upon the material what you are using. Okay, when the heat will be transferred through the material, okay, there is a reduction in the temperature, right? Because of the material. Okay, you can able to see one of the example, different material having different density, different resistance value. Okay, so this resistance value we are taking for the calculation purpose. This is one of the thermal properties of the material. Asphalt material, asbestos. Okay, then you have a roofing felt. Okay, then you have a asphalt shingles, cement. Okay, sand aggregate, gypsum plaster. So each and every value having a resistance, right?
Yeah.
Okay, this is the basic calculation which we are going to use it for many area. Okay, this is thermal capacitance and sensible heat transfer equation. This is thermal capacitance equation. Okay, heat transfer equation. So Q equal to mCp delta T. So you can remember this value will be used for most of the calculations. Okay, so you can see that even sensible load we will be using by this equation. Okay, and even if you talk about latent load, we'll be using this equation based on this heat transfer, right? Okay,
Yeah.
so you can able to see the equation Q equal to heat transfer, M equal to mass of the material. Depends upon the material, your heat will change, right? If you are using concrete, okay, your heat transfer will be different. If you are using brick, your heat will be different. If you are using normal gypsum partition, your heat transfer will be different. So depends upon the mass of the material. Okay, then the specific heat of that particular material. Okay, and the temperature change in material as a result of heat transfer from external to internal. What is the heat what is the heat you want to have a change in temperature? So depends upon that you are going to calculate the heat transfer, right? Say for example, if I have a 46 degrees Celsius, if I want to bring it to 40 degrees Celsius, then I need less energy. There is a less energy required. Okay, if I have to bring from 46 to 24, then I need more energy. So that is the way you are going to calculate what is the heat transfer.
So to just to
Yeah,
be clear on
tell
this
me,
equation,
Fang. Yeah,
Q is the heat transfer.
yeah.
That is the heat transfer required for be it or heating or cooling purpose.
No,
Anything.
both, anything,
Both, anything. Okay.
anything. Yes.
M,
This
when
is
you
kind
say
of,
mass of the material.
basically this is a mass flow equation. The mass can be heating or cooling.
Okay. So when
Yeah.
you say mass, it,
Heat
I
transfer.
mean
No,
mass
when
of
you
the
say
material.
mass of the material means what is the mass of the material? Your material properties. What type of material you are using? Okay,
No,
assume
no,
that.
no, 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 no. No, I'm not saying that because this particular thing we would have studied in our thermodynamics in the university. We refer it as mass flow equation in the heat transfer something subject. So the Q is the energy or the amount of heat, whether it can be the heating load or the cooling load. Okay, and MCP, the mass is basically the material in terms of kilogram. That's it.
And specific fit for each material would be constant, yeah.
Yes.
Yeah, specific
Already, maybe you
heat.
can just share one sample calculation, then he might
Yeah,
have
I
better
will share it. See,
understanding.
specific heat is nothing but you can see that this is the amount of energy needed to raise this temperature of 1 kg of a material by 1 degree Celsius. Assume that you have a different material, right? All the material is not uniform. Okay. Say for example, if I'm using concrete material, okay, of 1 kg of concrete, to to increase the temperature by 1 degree, you may require more energy, right?
Yes.
Yes, a specific area is clear. That is fine.
Yeah,
It is a
that is a
constant value
specific.
for each of the material.
Yeah, each of the material, right?
Okay.
So this is the
Right.
heat equation. This is a heat equation. Okay, I will share one of the sample example in the coming slide. Okay, so how to calculate the different type of heats. Okay, you will understand. Okay, let me finish this
Okay.
particular slides so you can able to understand, right? Then remember we talk about outdoor design condition. Okay, when calculating the thermal load for building, it is very important that the heating and cooling equipment system capable of maintaining adequate comfort under all reasonable condition, right? Okay, so whether it is a heating or cooling depends upon summer or winter, your equipment should be capable. Okay, so that is why we have a heater in the machine sometime and you have a cooling coil in the machine sometime, right? Okay, these are different properties of the air. We have seen last time how to read the ASHRAE METEO software, okay, to identify what is the temperature in different locations. Okay, this is the comfort requirement for the officers. What is the comfort during the winter and during the summer, right? So this is the comfort condition as per ASHRAE itself. Okay, you can see that ASHRAE handbook. In different location, what is the comfort requirement for the human comfort during the winter and during the summer? So when you design the air conditioning, you can able to bring from outside 46 degrees Celsius to 23.3 degrees Celsius, and during winter maybe 7 degrees Celsius, you can able to heat from 7 to 20 degrees Celsius. Okay, so that is the condition given here. Clear, Fagad? Okay, now load estimation based on CLTD method. Okay, so this is the basically the equation to calculate the roof load. Okay, you can able to see the equation, same heating equation, but it is different. U A CLTD. Okay, U is the U value, U factor, right? And A is the area of the roof, and then cooling temperature difference outside and internal. What is the temperature difference? So by using this equation, you can able to understand what is the heat transfer through the roof material, right? Clear, Fahad?
Clear. This is clear.
Okay, so this is the equation. How much heat you are going to transfer from outside to inside. Okay, depends upon the material and depends upon the area of the particular material. Okay, and it depends upon what is the temperature. Say for example, I need 24 degrees Celsius. Okay, and you have a external, say for example 46 degrees Celsius. Okay, so how much heat it will be transferred, which is affecting your internal load. Okay, so that is what you are going to calculate
Oh,
here.
just one doubt. In the
Yeah,
last one, CLTD, cooling
yeah,
load temperature difference. When we consider this is the difference between the external and internal temperature.
external and internal temperature. Yes.
Okay. Now, external temperature, we all know. So
46,
what is
for example.
outside the outside temperature? Internal
Yeah.
temperature. We are considering what we require or what exactly it is.
No,
I
what
mean,
we
like
require. What we require.
what we require. Okay.
Clear, right? Okay. Similarly for the wall load. Okay. If you have a wall, external wall. So the same equation. U equal to U factor for the wall. Here it is U factor for the roof. Okay. And you have a area of the wall, and then you have a cooling temperature difference. Cooling load temperature difference from external to internal. Same equation. But this is for wall, that is for roof. Clear, right?
Yeah.
Okay, then you have window material. Okay, so here also again you have a conduction, right? So this all conduction. It's a part of conduction. This is also conduction. This is also conduction. Okay, and you can see that window material depends upon the material. You have a heat
You
will be transferred through the material, right? So again the
Yeah.
same equation. Q equal to UA CLTD. Cooling temperature difference between outside and inside, and what is the U value for the glass for this material, right? And what is the area of that particular material? Okay, so this is the way you can calculate window load. Okay, you can able to see different materials, right? Aluminum material, okay, with a different single glazing, double glazing, okay, to calculate the U value, U factor. Okay, then you have a window load, right? So you can see that the equation Q equal to area of the calculated building plan. So like what is the area of the window? Okay, then the shading coefficient. This is a dimensionless value. Okay, if you have no idea, you can put 1. Okay, then the solar cooling load factor.
Panchita, just
Yeah.
2 minutes. I'll be out. I am receiving another important call. Just 2
Yeah,
minutes.
sure.
Sorry.
Shall I stop it or?
No, it's. Can you please, if you don't
Yeah,
mind?
yeah,
It's related to work. That's why.
sure.
Sorry.
I will. Yeah.